Okay, this is data recovery case 219970. This is an actual recovery that we're working on right now that was just shipped to us. The customer just requested for us to do a video documentation, kind of like we've done on a couple of other cases, and we hadn't done one in a while, so we thought this would be a great time to do it. This is a 1 terabyte Western Digital hard drive. The customer said that the drive had been working fine, and then suddenly it got to the point where it was operating slower and slower, and then it got to where they came in one day and it was just not powered up at all. They went to go power it up again, and the drive started making some clicking sounds. I'm going to go ahead and power it up briefly, just so you can kind of hear what we're hearing with the drive itself. So it's spinning up now. I'm going to move in close so you can hear it, because these are kind of quiet. Okay, that's enough of that. That gives you an idea of what these particular drives sound like. These are a little quieter than some of the older drives that you may have heard or may have seen in some of our other videos, where they're just kind of just this loud clacking sound. These are a little more subtle. But definitely, though, when you have an issue like that, you don't want to sit there and let the drive run for an extended period of time. With these drives here, what we can see sometimes is the actual head assembly towards the tip of the head, the actual where the read-write heads themselves are located. Sometimes there's some components there that start to come apart. The big thing we see are the sliders, which are these black, they look like just black squares on the end of the heads. A lot of people assume that those are the heads, but they actually are not. They are part of the overall construction of the head assembly, but they also allow for the heads to float above the platter surface. So they kind of give lift to the head as the air floats, as the air is circulated underneath them. But sometimes we see those start to come apart, and they actually will contact the platter and scratch it up a bit. So letting a drive run when it has any type of physical issue is definitely a risk as far as that's concerned. So we will go ahead and take this into our clean room environment, and we will start disassembling it. We've already done some other tests to this, so we know for sure it's the drive. Sometimes you can have an issue where it makes a clicking sound, but it's actually firmware related. Sometimes it can be in the electronics, but we've checked the electronics out okay and already, and they're fine, so there's nothing there. So now we'll go ahead and move to the next phase of it, and we'll open this drive up, see what we have, kind of determine what we need to do, and proceed from there.
Okay, I thought it'd be a good idea just to go ahead and narrate over this instead of trying to fight the noise from the air rushing around in that clean room environment that we have. Basically, we work under what's called a laminar flow hood, and it's highly filtered air that runs through multiple layers of filtering and creates a positive airflow, essentially pushing all of the dirt and debris that might be floating around in the air out and replaces it with highly filtered, very clean air, practically dust-free. So what that does is allow us to give a good environment for actually working on the internal components of the hard drives themselves. Hard drives are extremely intricate, and they're very fragile inside as far as their tolerances to dust and dirt contamination. Now, some newer drives we've seen come in, even from the factory that have never been opened, are absolutely filthy inside, so I don't know what standards have kind of gone down in that department for some manufacturers, but we have noticed that more and more drives started to come in, especially in the last year or so, with failed heads and things like that, and the drives are just so dirty inside, it's almost unbelievable. But right now I'm just going through and peeling off the labels off of the drive itself, and the little stickers that go over the screw holes and everything else. As far as doing this type of work, the physical part of the work, making the part replacements and things like that, it's involved, and we don't really show everything because of the fact that we have some components and some tools that we use are tools that we've developed ourselves. So the actual, moving and replacing the heads and things like that. There's ways you can get components for doing that on your own. But my thing has always been, if you have a drive that has data on it that you absolutely have to have, you definitely want to trust an experienced data recovery technician company to do that, not just your normal computer repair shop, not the $50 or $100 or $200 shops. They're not going to be able to help you. But our company, there's a few others out there that we actually even highlight on our website. Drive Savers, On Track. There's a few of them out there that are reputable companies that we have no problem even telling people absolutely. If you want to get a second opinion or anything like that, by all means check with them, but just make sure you use a reputable company. So there, I just took off the controller board, and the controller board is essentially what interfaces to the computer itself. It's got your power supply and in this case a SATA connection. What I'm doing here is actually peeling off it's like a sticker on the bottom of the drive so I can inspect the bottom platter surface. Just want to make sure that there's no damage at all to the bottom platter. And a lot of times if there's anything where the platter's been scored, even the top platter surface, being that that's a sticker, some debris will actually stick to the sticker itself, the sticker material. So it just gives us a little hint before we even open it as to kind of what we're dealing with. I mean, if we see just tons of looks like soot, attached to that, then we're pretty much done at that point. And once we get these last few screws out, with these drives here, in particular, the way the heads are mounted, the case cover itself is what actually controls the head alignment. So we have to go through, and we try to be careful with opening these, especially the older ones. These newer 1 terabyte, 2 terabyte, 3 terabytes aren't as intricate, but before we even do the recovery and before we even open them, we actually mark and take some measurements as far as placement of the case cover, so that we can go through and try to realign that as much as possible once the heads have been swapped out. But we try to pry up on it carefully. We don't want to bend the case cover at all. We don't want to warp it at all, because that case cover actually holds the heads in place. And if we go through and get that all warped up, which we see some drives come in where they've already been opened by somebody else, it makes it a little more difficult. And right here, we can tell that this is a pretty significant problem. The heads aren't actually even parked on the ramp. You can actually see there that they're just still on the platter surface. What that tells us is the sliders, which are the part of the drive which I mentioned earlier tend to fail on these particular Western Digitals, have come off. At least one of them has, and what that is in turn is it doesn't allow the drives to seat properly on the parking ramp. So basically what happens is they just sit there and they try to park, but they can't, because they're hitting up against the edge, the lip of the parking ramp itself, so they're just kind of stuck there. And that's really kind of a bad thing, because then what you have is when the slider's gone, the slider kind of acts like the wing on an airplane in some capacity, in that it allows the heads to float above the platter surface. So when they have come apart, which they tend to do a lot in Western Digital drives, then the base component, the metal component of the head assembly itself, is basically just sliding along the platter surface. It will go through and contact the platter, and as the platter is rotating at 7,200 RPM, it kind of acts like a grinder against the platter surface. And on the platter, the shiny part there is actually what stores your data. There's a very, very thin coating of ferromagnetic material, and that is what holds the data in place. and the heads themselves float above that platter surface on a cushion of air as the platter rotates, and it creates lift against those sliders. And on drives of this capacity, they got fairly tight data densities, and you're looking at the heads probably only floating maybe 6 to maybe 8 nanometers above the platter surface. And to put that in perspective, a strand of DNA is only about 2.5 nanometers wide, so that's how close the tolerances are. So now I'm getting ready to remove the damaged head, and I mentioned that these heads aren't mounted onto the drive chassis at all. They loosely fit in there, so you just have to go in, grab on each side of them, and then slide them up, and they'll come right out without having to unscrew anything at all. This particular head here was a little tricky to get out because it was kind of warped a bit. But as you can see, it just slides right up off there. There's no screw holding it in place, nothing. And that's the problem with some of these Western Digital drives. And when I looked at it, I could tell that 2 of the sliders were missing. So the next step becomes, where did the sliders go? If they aren't obviously hanging off the head stack assembly, then that means they're inside the drive still. So the next step becomes finding these tiny fragments, look like almost black pieces of dust, really, is what they look like when they're off the head. You have to go through and locate them. I got lucky on this one initially because one of them had actually caught itself on the magnet. And it's always nice when that happens, because sometimes you can actually have it to where the slider is almost bonded to the platter surface, and that's extremely difficult to deal with, especially if it's on the bottom side of, let's say, the bottom platter. You don't even know if it's there, you can't see it, and then if you go through and you swap the heads out, then you have an issue where the replacement heads are going to hit that little fragment that's still on the platter. And right here I'm just checking the filter, mainly to see if there's any fragments in there. The slider that I have rested on my finger right now is intact, so it wasn't busted up or anything. And there is another one in here that I think I noticed right around there, and then I realized that's what it is. It's the other slider. So both sliders are accounted for, which is a good thing because that means they're not stuck on the platter surface. And a lot of this, when you're dealing with hard drive recovery and repairing hard drives, things like that, you've got to be extremely careful how you work with them, for one thing, but also just knowing what to look for and things like that. Somebody might go through and try to swap out their heads and then not even realize that pieces of the heads are still actually in there. So then I'll go ahead and reinstall the parking ramp. I had to remove that because the heads would not come off the platter surface, and I didn't want to take any chances on risking the platter itself doing any damage at all to it. And surprisingly, with these particular drives, don't know why in particular with these, but when the sliders come apart, they don't always damage the platter surface, and when you look at it and the way that they sound, sometimes you'd almost think there's no way that they couldn't. So just now we've finished with the damaged drive, and now we'll start working with the parts drive so we can pull the heads and things like that we need out of this one. So now that we have our parts drive, we can go through and repeat the steps that we just took with the drive that's damaged. And there's really not a whole lot of action with this. There's not anything that's groundbreaking or anything like that. We're going through and repeating the steps. The only thing is this drive is not going to have the issue where the heads are resting on the platter or anything like that. I mean, it's a perfectly good working drive. And we'll do a quick inspection just to make sure that the head map is the same as far as the layout of the heads themselves. Sometimes you can have drives where there's different blanks The drives may be, for example, this one here in particular is set up to where it can actually use 3 platters and 6 heads, but it's only utilizing like a bottom platter and a top platter, and you have 2 heads on the bottom and 2 heads on the top, but there's just no middle section. So, but you can get drives to where they're the same model. Everything seems to match up on paper, but when you get them, the head mapping is slightly different. Maybe the bottom platter is not there, and it's just the middle and the top, or maybe the top platter is not there and it's just the middle and the bottom. So sometimes you can actually get away with getting, let's say, a 1.5 terabyte hard drive, for example, when you're dealing with drives of this size, like 1 terabytes and such, and you may actually have a set of heads that has all 6 of them in place and 3 platters and everything else, but you can still typically use those heads if everything else matches up, because the firmware is automatically going to think that those extra heads are just blanks. The problem that you run into, though, is trying to get them to mount back on the parking ramp and things like that. So, but there are ways that we can work around sometimes if we can't find an exact match that we need. Okay, and I'm not going to show the process of actually removing those heads, and then here we are finishing up the installation of them into the damaged drive. Mainly because of the way that we do it. It's just something that we do, and it's type of tool that we use, and I don't necessarily want to have us sharing that information with other companies or anything like that. There's plenty of places, if it's something that you just want to try on your own, that you can order assemblies and tools and stuff like that for swapping out heads. The actual swapping of the heads and getting the drive repaired in that way is only a small part of the process, though, because even after the heads are installed, you still need to be able to go through and get them to calibrate properly, and that's usually where the problem lies. We get countless drives in here where the actual method that was used was completely botched, and it usually ends up damaging the platter surface, or just some key steps were missed, sloppy work, things like that. And you really, once the heads are replaced, physically replacing them like this is not the biggest part of the process. The biggest part is actually getting the drive to where the data is even accessible again. So we'll go ahead and clean this platter off, replace the magnet, and be ready to go with trying to see if we can get the data imaged off of here.
Okay, we have the drive rebuilt, and we have it now connected to our imager. We've already gone through and done an initial step, which is essentially to go through and regain the head alignment. What we typically do is we just go through and we can either access some settings in the firmware itself, and we can actually allow it to be able to compensate for some misalignment that way. But also, too, sometimes it's just really just fine-tuning just the case cover itself. We may go through and loosen the case cover up some, and we may make slight adjustments back and forth, up and down, just until the center point of the head stack assembly is hitting the top of the case cover just where it needs to, so that it gains the track alignment that it needs to over the platter surface. It's really odd with Western Digital drives compared to others. Most hard drives are manufactured with the platters already having some of the data written to them, servo tracks and things like that, because then the heads are actually anchored to the drive chassis, so the alignments are always going to be the same from drive to drive. There's really not any variation. But if you may have recall when we disassembled this drive, we didn't really unscrew anything to remove the heads. The heads, we just worked them up off of the shaft in there. We just slid them up, and that was pretty much how a lot of Western Digitals are. So it's how they're assembled, and the platters go in there blank. The heads slip down over that shaft. The drive case cover is then put in place, and that is when the initial head alignment is essentially set. So there can be minute differences between drive to drive, but minute differences when you're talking about data densities that are so tight, the way they have here, and they're trying to pack so much data on each platter, even nanometers of variance can be a big deal. So anyway, we've gone through, run some tests on the drive itself, got the head alignment where it needs to be so that the drive should calibrate. I'm going to go ahead and power it up, and it's spinning up now. And actually what we're looking for up here in our imager is this light, and it says busy now because it's trying to calibrate, and it should go to ready. Well, it should. Yep, there we go. So that means the drive is calibrated. This right here is going to be indicating our destination drive that we're going to be cloning the data to. And I'll go through and rescan the drives that are available. And there is our drive that we're going to be recovering from. And you always want to clone a hard drive. You don't want to go through and work from the source drive. And what I'm going to do is just pause just for 1 second while I put this camera up over my shoulder so I don't have to hold it while I'm doing some of the other steps that I need to here. Okay, so we have our source drive, we have our destination drive. I'm going to go through, and the first thing we're going to do is pre-configure the source drive. We don't want this to try to utilize its normal firmware function and try to reread bad sectors or anything like that. We don't want it to force itself to do anything. We just want it to kind of go through and be as easy as it possibly can for the drive itself, because we don't know how much life we'll have, and we don't want to hit a bad sector or some areas of the drive that might be damaged or something like that, and then have it forcing itself to try to keep rereading those areas. The next thing we'll do is we'll go through and generate what's called a head map, and we'll select our drive brand here. And a head map is essentially just laying out the sectors on the drive as far as which head is reading which sectors. There's a couple of really good advantages to this. First of all, you have a lot of flexibility over how to handle platter surfaces that might be damaged or heads that might be degraded. Because there's sometimes that we have a drive that comes in and a customer just can't afford to do a full-blown physical recovery, because they can get expensive. But there's enough flexibility there for us to where we can go in, and if the drive doesn't have any obvious signs, let's say they're looking for pictures, if the drive's not clicking but one of the heads is degraded severely, we can actually generate this head map. And what this is doing, you see 0, 1, 2, 3, it's just kind of all over the place. And this tells you how many sectors each head is reading, so roughly 300,000 sectors before it switches to the next head. And this is the sector that head starts reading at. So that's what it's doing. It's scrolling through these and mapping out the areas of the drive that each head images. So what I was saying before, to get back to that, is if you have a customer that comes in that just cannot afford to do a physical recovery, well, in some drives we can go through and actually look at the head. We can generate a head map still, and if we say, okay, well, one of the heads has definitely failed, then we can deactivate that head and image the remaining good heads. Now, in some drives like Seagate's, the order of the head map is in a sequential format. It's more orderly than these Western Digitals are. So you may have it to where it reads head 0, 1, 2, 3, and then 3, 2, 1, 0, and then 0, 1, 2, 3, and then 3, 2, 1, 0, just back and forth, up and down like that, and it's perfect. Because then, even if you deactivate one head, you're still going to get huge chunks of data. Let's say head 0 is bad. You're still going to get head 1, 2, 3, 3, 2, 1, and then it's going to skip head 0, and then go back to 1, 2, 3, 3, 2, 1. So you have huge chunks of data that are still being read, which is, if you're looking for pictures or something like that, that may mean that we can get 70 to 75%, maybe even 80% of the pictures that were there initially, depending on where they're laid out on the platter. I mean, really, depending on how big the files are and where they're laid out on the platter surface and the overall capacity of the drive, we could mean that we get the majority of the pictures, and we've had that happen before too. So this is almost done, and then what we'll do is we'll just test the heads to make sure that they all read good. So the head map is complete. We'll go up here and we'll do a media test, and basically that's what this is going to do, is just test out the heads. If we had an issue with any of these, which they look good, it would come up with errors along here for whichever head that is. So this is our head number 0, 1, 2, 3. And from here, we will go through and generate what's called a bitmap. And I can't stress enough, like, as far as doing this type of work, the actual physical part of replacing the heads, yeah, a lot of people can get, a bunch of parts drives and just practice, practice, practice. There's lots of sources out there for, well, maybe not lots, but there's plenty of sources out there for finding parts for head combs and things like that to keep the heads separated. And there's little do-it-yourself type, information out there as well. The physical part of actually swapping the heads is not as big a deal, really, as being able to work with the drive after the heads have been swapped out. I can guarantee you, without a shadow of a doubt, we could take this drive, put it onto a PC just through a USB type enclosure or something like that, or connect it directly, and you won't be able to gain access to any of the data on here. The drive's going to act really flaky. It's going to be probably in a really degraded state. It may end up being to where if there's an issue with the platter surface itself being damaged, that you may end up damaging these replacement heads. There's really a lot of limitation once the heads are swapped out to be able to actually start the process of recovering the data, and that's where having the investment and the equipment comes in handy. And we use DeepSpar disk imagers. That's what we have, multiple imaging stations like this here, and they allow you the flexibility. They're not like normal cloning software that's out there. These are hardware-based imagers. So the first step in this is we want to make sure that we recover the data that our customer needs. We don't want to waste time in the life of the drive imaging stuff that they don't really care about. And this customer was emphatic. They only want their JPEG images. Well, we're still going to go back, and if this works, we're going to go back and image everything else just to make sure nothing's missed. But our first and only priority at this point in time is to generate the JPEG images. So we're going to go through and select the imaging area, and this is going to generate the number, whatever partitions are on here. It could be 1, 2, 3, sometimes 4, whatever, how many partitions there are, it's going to tell us. And then once we have the partitions, we'll be able to know which ones generally hold the user data in it. Oh, there's just one, so we don't even have to get into that. So right now we're going to go through and select all of the data, just mainly because we want to see how much data is on this drive overall, and it won't take that long to do it. Once we have an idea of how much data there is, I mean, if there was only, let's say, 20 or 30 gigs on this drive, then we would probably just go through and image it all from the start. But if there's more than about 50, we'll go through and just separate out just the JPEG files, since that's what they need. So right now it's going through and generating the bitmap, and it's selecting all of the sectors that will be allocated towards that bitmap. And a bitmap is basically just the layout of the data on the drive. And looking at this, it looks like we have a total of 871 gigs of data on this drive, so it's almost full. This is a 1 terabyte. So we're definitely not going to go through and just have it start from the beginning and image the entire drive initially, because I'd hate to get 10 or 15% into the drive and then all of a sudden the heads fail and we've lost a ton of data on here. Or, there's a number of things that can happen. So we'll go through and let's unselect this, and then we'll go back and just focus strictly on just generating a selection of only JPEG files. Take it just a second. There we go. Okay, so we're going to select the imaging of select the data, the area that we want to image. Select specific files. Right now, I want to get all the JPEG files, no matter what directory they're in. So I'm just going to put an asterisk there. I don't care what the file names are, so put an asterisk there. And then we're going to look for everything with that extension, with the JPEG extension. Now, if we had a customer that only wanted, let's say, QuickBooks files, we would just put a QBW here, or Word documents, etc. If they only had, let's say, one specific file that they needed, for sure, like they absolutely had to have my company, .qbw QuickBooks file, then we would put that here, and then just ignore everything else. Because basically, what that's going to do is it's only going to look for the sectors that contain that particular file. But since it doesn't matter to us what directories they're in, what file names are, we want everything with the JPEG file extension, we're going to hit enter. And now that's what it's doing, is it's looking for everything that has a JPEG file extension. You can actually see the JPEG here. And we have enough of the data, enough of the drive imaged in that bitmap to be able to actually tell us directories, subdirectories, file names, etc. So we have a lot of information there just to know that yes, the data is all there. If one of our customers only needs their documents and they're not sure what all they have on there, but they definitely want everything within their documents directory, then we would go back into that screen that we were just on and select like either the documents settings directory or the users directory, and then asterisk the rest of those. So this is probably going to take a little while. It's only at 2% right now, so there's probably a lot of data on here. And we're going to go through and just let this run, and then once the JPEG files have been selected, then we will get started with the next step, which should be actually just recovering, imaging those files to the destination drive. And once that's done, then we'll go back and image the remaining portions of the drive. Okay, we have all of our files selected, the sectors selected that we want to image at first. We can see here, because we just selected JPEG files, so we can see here that there was 36,316 of them, about 78 gigs total. So there's a lot of JPEG image files on here. So essentially what we're going to do now is start the imaging process. And so our first pass is going to be imaging just the sectors that contain those JPEG files. Those are the sectors that are selected. And you may or may not be able to see back here on the little sector marks here, there's little check marks, and everywhere there's a check mark underneath there is a sector that's going to be imaged. So we're going to go through and we're going to start at the very beginning of the drive, and we're going to image just the selected area, so only the sectors that contain those files that we are looking for here at first. So it's all good, and it'll start from the beginning, and you'll see it kind of flash green. And those are areas that it's basically imaging right now. The gray areas are areas of the drive that it's skipping right now. And what it'll do is it'll go through and only image, like we said, those sectors that have been selected that actually contain JPEG files in them. So you can see there's a lot of areas here that are just gray as it scrolls through, and there's nothing there. And then every once in a while it'll hit a section, and that's where one of our images are that we're trying to recover from. So we're going to go ahead and let this run, and it looks like based on what we see here initially that the recovery itself is going to be a success. If for some reason something comes up and something changes, or this set of heads or something like that fails, then we'll deal with that at that time, and probably bring the video back up as well. But for now, it looks like it's going to go through, and we'll get these images, the pictures and stuff, imaged and cloned over at first, and then we'll go back and we'll select everything else and image the remaining portion of the drive. Now, every recovery that we do includes a free evaluation, so there's no charge at all for us to take a look at the drive and just kind of determine what the problem is with it. If the recovery is successful, we put the data onto a new external drive, and that's included with the price as well. We don't charge anything for the evaluation process, and we don't charge anything if the data is not recoverable in most cases. The only exception to that is in cases where the hard drive itself has already been opened. But if you have any questions at all about our services or the process itself, please give us a call at 1-800-717-8974. Our website is acsdata.com, and we have tons of information on there as well. But that's pretty much it for this recovery. Thanks for watching.